Algebra 3, Chapter 5, Section 2, Logarithmic Functions and Graphs. Okay, a logarithm is the inverse of an exponential function. So the exponential looks like y equals a to the x. Switch x and y. And then the inverse function is log base a of x equals y. So notice where everything is in relation to the original. The base is now after the word log. It's kind of a subscript. The log base a of x is y. Another way of reading it is a to the y power gives you x. So the log base 2 of a is 3, means 2 to the third equals 8. And the log base 5, 625 equals 4, means 5 to the fourth gives you 625. Now your calculator has two logarithms on the keyboard. They're both right, one above the other. The first one is the common log, which is base 10, and that's the one that just says log. The second one is the natural log, which is base e, and that is ln. And notice that the second functions for both of those are their inverses. Log is base 10, and its second function is 10 to the x. Natural log is base e, and its second function is e to the x. So that really helps you remember which goes with which. Now, these two keys only work for base 10 and for the natural base, not for any other bases. So don't try to use them for bases other than 10. The log of any base of 1 equals 0. In other words, log base a of 1 equals 0 because any number to the 0 power is 1. The log of any base of itself equals 1. In other words, log base a of a is 1 because a to the first is a. The inverse property says that the log base a of a to the x equals x. In other words, it's like the a's cancel. Or a to the log base a of x power equals x. You're composing the original and the inverse, and they cancel each other out and just leave you with x, which is what inverses do. The equality property says if the log base a of x equals the log base a of y, then x and y must be the same, which makes common sense. Logarithms are the inverse of the exponential functions. The graphs are reflections of the exponential functions about the line y equals x. So here you see y equals 10 to the x and y equals the common log of x. The green line is the line y equals x, and you can see how the red and the blue are reflections of each other around that line. The logarithmic functions have vertical asymptotes rather than horizontal. Again, it makes sense. The exponential have horizontal, logarithmic have vertical. The natural logarithm is the inverse of y equals e to the x, so you can see again the reflection across the line y equals x. The natural log of any base of 1 equals 0. These are the same properties. It's just specifically for the natural log, but they're the same as what we just saw a minute ago for any log. The natural log of any base of itself equals 1, so the natural log of e is 1. The inverse property says that when you compose the natural log and the e to the x, you just get x. And the equality property says that if the natural log of x equals the natural log of y, then x equals y. Again, same properties, just making it specific for the natural log. All right, so evaluate the function at the given x without using a calculator. Pause the recording, give this a try, and resume to check your answer. Okay, log base 8 of 1 is 0 because 8 to the 0 is 1. And for g, we've got log base a of a squared, that's 2 because a to the second power is a squared. Or you could also use the inverse property, which says log base a of a, the two a's just cancel and leave you with 2. All right, give these two a try, pause the recording, and resume to check your answer. Okay, the first one is 7 because 11 to the 7th equals 7, or again, they cancel each other out, they're inverses. And this one, x plus 1 must equal 6 because you have log base 5 on both sides, so x must be 5. All right, we're going to write this in exponential form. In other words, write it as its inverse. Pause the recording and give this a try. Resume to check your answer. This is very simply e to the negative 0.693 equals 1/2. Do the same thing with the second, only this time we're starting with the exponential and rewriting it as a log. And that gives us that the natural log of 7.3890 must equal 2, or in other words, log base e of 7.3890 equals 2. Okay, now try these two problems. Pause the recording, give them a try, and resume to check your answer. This first one's similar to ones we did earlier. The natural log of e to the 5th is 5 because the natural log and the e cancel each other out. And for the second one, well, x squared minus 2 must equal 23. And solving, we get that x is plus or minus 5. All right, now try this problem. All you're doing really is you're putting these numbers into the equation and completing the table and then graphing. Pause the recording, give this a try, and resume to check your answer.